Today's lecture is a continuation of the previous one. Okay. So what we are going to do, what we did the previous time, we did energy, look at the forms, and then we did the conservation principles. So we had one more slide before our time ran out. So you look at that slide today before we move on to the next topics. All right. So this was the problem that we had with us. We have a motor vehicle of mass 800 kilograms, and it stands on an incline whose gradient is 1 in 10. So our vehicle is standing on a hill or slope. The handbrake is released and the vehicle runs down the incline. If the frictional resistance, there is friction to the motion is 40 newtons, find the speed of the vehicle. So we are supposed to find the speed of the vehicle after after running 200 meters. Supposed to find the speed after running 200 meters. So V is our problem, okay? And then we have the mass giving us 800 kilogram. The distance giving us what 200 meters. Gradient is given to us as gradient is equal to 1 over 10. So let's look at what these things mean. We have a slope and then we have our vehicle on it. Okay, we have our vehicle that is sitting somewhere here on that slope. Okay, now what we are saying is that on this, the gradient is 1 in 5. What that means is that for every 10 meters, 1 in 10, for every 10 meters, we go up by 1. Okay, so if you travel 10, then we are up by 1 meter. You travel horizontal distance of 20, which is another 10. Then we are up by what? 2 meters. 30. We are by 3 meters. So that is what it means. Okay. So we've been asked to find the velocity with friction in place. What we're looking at is that the PE over here should be equal to the KE over here, but then there's friction. Okay. So because there's friction is going to take some of the energy, that is the work done against friction. So we must find these three variables in order to find the velocity, which is related to the Ke. Okay. So Pe is equal to mass times gravity times height. We know mass, we know gravity, but we don't know height. Okay. So let's add R to gradient so that it doesn't confuse us. We don't know height, so we must find the height. Now, from what we just analyzed here, the 1 in 10, it means that gradient or the height is equal to the gradient times the distance traveled, which will give us 1 over 10 times 200. Okay, so we get our height as 20 meters from here. We have our height, so it's now easier to find the potential energy where P will now be equal to the 800 times gravity, which is 9.81 times the 20. Okay, and we get the value of Pe is going to be in joules. Okay, so we have Pe. We know that Pe, because of friction, Pe is not equal to the Ke because of what? Friction. But Pe is equal to the Ke plus the work done against friction. Okay, we know Ke, we know Pe. We must find the work done against friction, which is equal to the frictional force that is given in the question over here, 40 Newton. Okay, frictional force is given times the distance, and that will give us 40 times what? 200. So we can get frictional force or the work done against friction as around 8,000 joules. Yes. Okay, we have that. So we have this, we have this. We now want to find the KE. So we can have KE is equal to PE minus break down against friction, okay? This is deduced from over here, continuation there. So once you do this, the PE minus the 8,000, that will give you the value for the KE. So you have the value for the KE also in what? Joules. You can do your computation and then you continue. Or you can pause the video when you get to sessions where there is empty space for you to fill, okay? So after finding this, we know that KE is equal to 1 over 2 mv squared. This is the V we are looking for. So that means you must make the V what? The subject. So by making it the subject, multiply through by 2, which gives us 2 KE. This will now go to the other side and divide. M is equal to V squared. The square here, V is not standing alone. So you bring what? Square root of this. Square root of this, which will take this one out. And you get your V is equal to K 2KE square root of 2KE all over M. So you put in your values now and then you solve to get your answer. Good luck.